prove that if delta is any fixed positive number less than unity, that is, delta is fixed positive number but less than unity, then the infinite series on n plus 1 into x to the power n converges uniformly in open interval minus delta to delta. So this is nothing but the interval of x, which means mod of x is less than equal to delta, right? So again we need to apply the Weierstrass-Zamm test over here, and there is also a need of D'Alembert's test. So let's recall the D'Alembert's test first. What it says: the infinite series on an converges if limit n tends to infinity an divided by an plus 1 is strictly greater than 1. So the series converges if this limit is strictly greater than 1. Some students write this as in the numerator an plus 1, then in the denominator an, the reciprocal. Then in that case, this limit must be strictly less than 1 for the series to be convergent, right? So whatever way you want to learn from that, right? Second, and it diverges if limit is strictly less than 1. Let's start with the proof. Now this is the infinite series given to us. We need to prove that it converges uniformly in interval minus delta to delta, right? And delta here given to be as a strictly positive number which is less than unity. Let's consider the mod of this first. This is further equal to summation n going from 1 to infinity mod of n plus 1 into mod of x to the power n. And is further equal to, because n is starting from 1 to infinity, so mod of n plus 1 is n plus 1 only, and this can be written as mod of x to the power n. Now as x is belonging to the given interval minus delta to delta, that implies mod of x is less than equal to delta. So this implies mod of x to the power n is less than equal to delta to the power n. Let's use this over here. So this is less than equal to summation n going from 1 to infinity n plus 1 delta to the power n. So what we are getting? Summation n going from 1 to infinity mod of n plus 1 x to the power n. This is less than equal to summation n going from 1 to infinity n plus 1 into delta to the power n. Please mark this as 1. Because I need to use a D'Alembert's test over here, so for that I need this an, the infinite series on an. Now this right hand side is also an infinite series. So let's consider n plus 1 into delta to the power n to be an. So let an is equal to n plus 1 into delta to the power n. Then an plus 1 becomes, just replacing this n by n plus 1, we get n plus 2 into delta to the power n plus 1, right? So now we need to find the ratio an divided by an plus 1. So that is equal to n plus 1 into delta to the power n divided by n plus 2 into delta to the power n plus 1. That is equal to n plus 1 into delta to the power n divided by n plus 2 into delta to the power n into delta. So this can be written as this. So this cancelled out. Now before applying the limit n tends to infinity, first let's take this n common from the numerator and denominator. So that is equal to n into 1 plus 1 divided by n into 1 plus 2 by n into delta. So this n cancelled out. And now let's apply the limit n tends to infinity on an divided by an plus 1 for this D'Alembert's test. And if this limit is greater than 1, then we say that that series is convergent. So let's apply the limit. Limit n tends to infinity, an divided by an plus 1 is equal to limit n tends to infinity, that is 1 plus 1 by n divided by 1 plus 2 by n into delta. So this is 1 plus 1 by n divided by 1 plus 2 by n into delta. So this becomes 1 plus 0 divided by 1 plus 0 into delta. that is equal to 1 over delta. Now it is given that delta is strictly less than 1, which means 1 over delta is strictly greater than 1. So that means 1 over delta is greater than 1, which means this limit is greater than 1. So this implies limit n tends to infinity, an divided by an plus 1 is strictly greater than 1, which means it is the condition for, so by D'Alembert's test, this is the condition for convergent series. So therefore, by D'Alembert's test, the series summation n going from 1 to infinity, n plus 1 delta the power n is convergent. So this right hand side is convergent, which is your Mn, right? Thus, from 1 by Weierstrass-Zamm test, the given series converges uniformly in open interval minus delta to delta. Hence the result